Welcome to Red Talks Daily International. Today we have Dr. Saratha from University Science Malaysia to speak to us on neurosymbolic integration and agent based modeling. We welcome you, madam.
Okay, a very good morning to ladies and gentlemen. Today, I would like to present my talk regarding neurosymbolic integration and agent-based modeling. First of all, I would like to thank Dr. Ratnakar and IMRF Foundation to give me an opportunity to share my knowledge regarding neural networks today. My name is Associate Professor Dr. Saratha and I'm from University Science Malaysia. So, any inquiries or questions related to my presentation today, you are welcome to email me at saratha@usm.my. So let us go for my talk today. As what you can see in the screen, my talk today is related to neurosymbolic integrations and agent-based modeling. Neurosymbolic integrations have two paradigma hidden in it, that is neural network and logic programming. In my work, I would like to combine both neural network and logic programming through a paradigm called as agent-based modeling. And I'm working with Hopfield neural network. This is a type of the neural network which is recurrent type and is used for pattern recognitions and content accessible memory, and also to solve some optimization types of problems. If you recall, it's used to solve traveling salesman problems, and queen problem and colony problems, and there are a lot of problems which we can solve by using this method. Okay, so if you see, let us justify why we want to integrate these neural networks and logic programming. So if you see, these both neural networks and logic programming has its advantage and disadvantages, which I will be explaining in my talk later. So let us move to my talks today. Neurosymbolic integrations and agent-based modeling. So, the main objective of my talk today is to find a best way to achieve the best global minima, and I want to integrate Boltzmann machine and hyperbolic tangent activation functions. In my talk today, I just will go through hyperbolic tangent activation functions because of time constraint, and I skip the Boltzmann machine and MFT, and I will look into why we need agent-based modeling by using NetLogo, why we want to focus on agent-based modeling, why not any other platform, why I choose this particular platform in implementing my work in neural networks, and also we will see how this model is used to test some real life and simulated data sets. Okay, there are few ways of testing this real life and simulated data sets comparisons performance. We are going to use Hamming distance, global minima ratio, RMSE, root mean squared error, sum squared error, squared Bayesian criterions, and so many ways we can use to analyze the performance comparisons between the existing and also the integrated method. And lastly, from the agent-based modeling that we have designed, we can carry out some computer simulation to test and verify whether the agent-based modeling that we have developed is efficient enough or not. So, if I talk about logic programming or Hopfield neural network, or sometimes known as direct method, this is actually pioneered by my supervisors Pro and Abdullah and also me. This is a way on how to minimize the oscillations and local minima values in increasing the effectiveness in performance of Hopfield network. This techniques is actually based on the energy minimization scheme, and we restricted earlier to program classes of up to 3 atoms, but now we have find a way how to solve until case satisfiability problems by using this logic programming. What we do here is we integrate this direct method with some acceleration techniques such as meta-heuristic algorithms, optimizations methods, and some other accelerations techniques such as modified election algorithms and so on. So all this method clearly has accelerated and has increased the uh, limitness in processing the network by using higher order network. So now by using a lot of new techniques, acceleration methods, I can increase my network's performance. Okay, what actually I did? We derive a learning algorithm which is time-consuming stochastic measurements such as mean field theory, which integrated Boltzmann machines that is simulating annealing, play with temperature, and also with activation methods known as hyperbolic tangent activation function. I integrate these two methods recently to accelerate the case-set problems. So what actually happened is energy function for Hopfield network is solved for a sequence of temperature of appropriate unit clamp. So when, for example, if the neurons have trapped in local minima, what I do, I increase the temperature. That means I heat up the neurons so that it has enough energy to jump the energy barrier and relax into global minima values. So this actually happening is in the program. Okay, so the rest of the algorithms follow the Boltzmann machine updating, and this algorithm is operating parallelly. That means it's not separately. Oh, I do this first and then only I do this. No, this is operate together. Okay, so let us start from the basic. What is actually neural networks? This is actually an information processing paradigm that is inspired the way such as our brain process informations. It has a large number of highly interconnected processing elements known as neurons that usually operates in parallel. This is an example of a simple neural network. We have an input layer, we have a hidden layer and output layer. Okay, to be connecting with a real life agenda, let me take an example. Knee jerk. What happened? If I knock my knee with some hammer or what, I quickly will take off my knee. Why? Because my brain said, oh, your knee is pain because it's been hit by hammer. So please take it away. So this one, although the word I used to describe take a few words, but this process happens very reflexive. That means it will happen very fast in our brain. When got some reaction like this, like knock, what happened? Our brain will create impulse in the brain, instructing us to do a reflexive action. So the reflexive action is jerk the knee. This is the same way how a neural network works. Okay, we have the input, that is the knock. We have the hidden layer, how the info is interpreted in our brain, and we have the output, what we should do. But if you see here, neural network can be divided into two types of network. Feed forward, that means the signals propagated towards forward the network. In feedback or recurrent network, what happened? The output will be feedback again to the input, and this process is repeated until we can minimize the error. That means what we want in the tolerance value very small. There are few networks I have listed here for feed-forward network and also for recurrent networks. Here, the Hopfield network has been listed where I'm working on it lah. Okay, if I see the advantage of neural network, this is robust. That means, for example, you go to a bank. Okay, you do fingerprint tracing, right? What will happen if your fingerprint has some dirt? Okay, can the computer still recall your identity even though your fingerprint got some dust? Yeah, sure. Because what happened, the computer already have a memory on your fingerprint. So although some information is missing in your thumbprint during the process, the neural network that has been implemented has the capability to reconstruct your thumbprint. Because of that, the computer can match your dirt fingerprint with the existing fingerprint in the computer memory. So this is what we call robust, and this process works very fast. That's why we can say neural network is very good in pattern recognition type of problem. And then this is self-organized. When I put my fingerprint in, I already give the input. The computer can see, oh, this is my input. Or the computer or the neural networks knows my task is to match the individual's current fingerprint with the existing fingerprint in the system. Is it matching? So the neural network itself is organizing what it must do. And this is through adaptive learning. That means we have trained the neural network. This is what you should do. Okay. However, as I said, the neural network has some disadvantages. That is, the major one is its black box model. For example, the knee jerk. I take off the knee. I have taken the new, but I don't know why in my brain the reaction has been implemented. How my brain knows that this is the proper action to the knee jerk. Okay, so what I'm trying to say here is we know the input, we know the output, but we don't know how the information is being processed. So that is the problems that researchers like me are trying to solve. We want to find the way how we want to elaborate how the information is being processed. Is it effectively, how fast it's being processed, and so on. And this neural network is in a non-symbolic form. Okay, and it cannot represent structure object. That means it cannot control C programs, Java programs, or anything. And that's why this has been classified in a low level of intelligence. Okay, so due to all these problems in neural network, we will try to integrate it with logic programming. Okay, this logic programming, from the name itself, program. So we need a platform to train the logic. For example, C program, MATLAB, Mathematica, and so on. All these programs have toolbox developed for solving neural networks. So this logic programming consists of program clauses and activated by an initial goal statement. It describes relationship among propositions and relationship between assumptions and conclusions. For example, one morning, I go out from my house, I see the grass is wet. There are few assumptions why the grass get wet. One, it might have rained yesterday night, or maybe somebody has poured the water in it. So what happened? This logic programming tried to tackle how much is the probability of raining, how much is the probability of people pouring the water. So it will try to process and bring us the output which is more related assumptions, which is highly can be accepted for the glass to be wet. Okay. However, this logic programming also have some advantages and disadvantages. If you see the advantages of this logic programming is human readable and writable, and it will return true or false, and it's a very highly recursive and structured data. But don't forget, this one need programming. A bracket missing in the program also will make the program to hang, and we cannot run the program. A good knowledge in programming is needed to handle this logic programming. Because of that, this logic programming we said is brittle, and we require expert knowledge, that is programming knowledge. Okay, so if you see here, to overcome the disadvantages in the both paradigm, researchers has come out to integrate both these inside a paradigm known as neurosymbolic integration. Okay. So I'm going to work on I'm working on Hotfield network, which is an associative memory is an important resource for intelligent behavior. For example, the thumbprint problem is a pattern recognition and is usually associated with Hotfield network. In Hotfield network, there is an energy functions known as Liabiano energy functions. These energy functions need to be minimized in order for the neurons to rest into a global minima values. This Hotfield network is fully interconnected type of neural network, and the network has symmetric weights. Okay, so why I choose out of so many networks, why I like to work with Hotfield network? Because it has distributed and asynchronous control. It has contra-accessible memory criteria, and nevertheless, it also has fault tolerance. That means missing information also it can reconstruct or rebuild the information. Okay. So let us see how this neurosymbolic integration is being implemented. That is logic programming and with Hotfield network. What I do is optimizations of logical consistency is carried out by the network after the connection strengths are defined. That means I equal the energy function with the connection cost functions, and I'll calculate the corresponding synaptic weights. And then I put the neurons into an energy relaxation schemes, and then I let the neurons to relax. The final state I check whether it's a stable state, where the is a state keep on changing or already stable. So that is the model or set of interpretations which are taken as the output for the corresponding logic programming. Okay, this is what has been listed here. We start with this, we initialize all the connection strengths and then translate into Boolean algebraic form, then identify a neuron, let the neural network involve and get the model. For example, consider this following logic programming. I want to solve this logic programming. So firstly, I will translate all these programs into logical clauses. This is what the logical clauses. And then I write down the cost functions related with the logic programming, and I compare with energy function, and then I will calculate what is my connection strength, which is listed as J here. Then I use the updating rule to see whether the neuron state has been changed and been stable or not. So the local field is created by the neurons while relaxing. This local field will measure whether the neurons has been relaxed or not. Okay, so this is the corresponding and the connection strengths to the logic programming. So the important thing is the activation functions. This activation function explain how the input is being transferred from one layer to another layer. Okay, here we want to find whether the activation is 0 or 1, or in another one is -1 or 1. That means is it firing or resting. Usually there are two types of activation functions, linear or non-linear. But in basically the primitive type of direct method use the sigmoid or logistic activation function, which should look like a bell shape. Okay, but the problem with this is this logistic sigmoid function can cause the neural network to stuck at the training time. But the good thing of this energy function is it is differentiable, so it can be used to find slope of the sigmoid curve at any 2 points. Okay. Because of the limitations of sigmoid activation function, we have come out with hyperbolic tangent activation functions. As what I said, these hyperbolic tangent activation functions use integrations of Boltzmann machines criteria of temperature, and also using uh, uh, another functions known as here. You see, hyperbolic tangent activation functions use the hyperbolic function and also the Boltzmann machine in order to find the next state of the neurons. So let us see the difference between the hyperbolic and the sigmoid, and sometimes known as maculate bits updating function. So here the hyperbolic is from -1 to 1, and this one is 0 to 1, and this is for bonded function. And here we can see that I can use differentiable equations to find my next output. So this is more stable if compared with maculate bits. Okay, now we have finished the first part of neural networks. Now another part is known as agent-based modeling. Okay, agent-based modeling, which is also called individual-based modeling, is a new computational modeling paradigm, which is an analyzing system that represents the agents that involving and simulating of this interaction. This agent-based modeling has been developed by Urinsky, and he used NetLogo. This NetLogo is very similar to Java and C program, but it's very user-friendly if compared with C. Okay, what is this ABM? Is actually is a three-dimension animation. I can see the interactions between the neuron in a three-dimension way, which is more easier to interpret my results. And even though this ABM is a bit harder in using NetLogo, but once you get used with the NetLogo functions, it is very easier and friendly if compared with other platforms. Okay, this NetLogo use programming language Java and is a user-friendly as what I said. Okay, the model can be viewed either in 2-dimension or 3-dimension, and it has interesting agent shapes which you can use to design. Okay. So example, this is screenshot which I get for agent-based modeling. So I can see the interaction between the neurons in a very colorful, attractive way. So this is a very, actually in agent-based modeling in in NetLogo, I can even see how these neurons are integrated or interconnected with each other. I can see it moving all the way to until it relaxes to the global values. So this is the screenshot of agent-based modeling, and I can get the picture and the output. This is a 2-dimension output, but I can design also here some graphic to make it more interesting. Okay, this is another examples of agent-based modeling. And as what I mentioned, we said we want to compare the performance. Surely there are some parameters where we want to use to compare the performance. In this presentation, I just discussed global minima ratio, Hamming distance, and CPU time. But for higher level, you can use RMS, that is root mean square error, sum squared error, mean squared error, square Bayesian criterion. There are a lot of parameters there which you can use to measure how effective is the performance is. So here I use 3 types of parameter where I compare with 3 types of algorithms to see which algorithms works better. And clearly here mean field theory works better because it integrates these both. Same like neurosymbolic integration, mean field theory take the advantage of these two. So sure, mean field theory can work outperform performance of Boltzmann and hyperbolic. So if you're interested with this mean field theory, you can find in Google some of my papers which has been published in mean field theory, and there is one paper is upcoming in mathematical research journal of IMRF publisher. So you can download this paper to get more information about MFT. Okay, this is for higher order network. As what I said previously, when this algorithm or approach is being introduced, we just limited it to 3 order only. But now I can move to K set, that means K order. Okay. This is lower order, some of the real life result of a school students. How is their performance? And this is to see the animals in data zoos, how they interact with each other. Okay. So as a conclusion, I can say that MFT is better and is in progress on enhancing the performance. Okay, so I can say that the integrations of neural networks and logic programming in agent-based modeling is the best way to solve the problem. So that's all for my talk today. Thank you again so much to IMRF and all my audience today. So again, any questions related to my talk, you all can kindly email me at Saratha, Saratha, at usm.my. Okay, thank you so much, and hopefully, I have chance to meet you all and share my knowledge again in future. Thank you.
Thank you, madam. I take this opportunity to thank Dr. Sartha Sathasivam for her informative speech on neurosymbolic integration and agent based modeling. Today, artificial intelligence has become the ruler of all sciences, whereas artificial intelligence is the simulation of human intelligence in machines that are programmed to think like humans and mimic their actions. Nothing but neural networking. I believe that today Dr. Saratha's talk have enlightened us the modeling structure to carry on machine learning, deep learning, etc. Thank you, madam. We congratulate Dr. Saratha Sathasivam and honor her today with the Red Talks honor title Red Talks Global Speaker. I thank all the virtual audience for participating in this interesting and informative talk. www.redtalks.net is our official website. Please visit for upcoming programs. You may also like us on Facebook, facebook.com/redtalks daily for regular updates. We have regular scientific talks on Red Talks. Thank you all. Signing off, Dr. Ratnakar, Director, Red Talks.